I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss concepts about cross product, see how do we calculate cross product, and look into its application. Let us now understand the concepts with the student Akshit. You can enjoy the journey of success and participate. Hi Akshit, how are you doing?
Hi, sir. I'm doing well. How are you?
Very good, very good. So today, what do you want to learn?
Sir, today I was hoping we can discuss the cross product.
Sure, yeah. Do you have any questions from whatever you've done at school so far?
Yes, sir, I actually do. I came across this question in my textbook and it was a bit complicated, so I was hoping we can go over it.
Sure. So share that question. Let me explain you, and then we'll
Yeah,
begin with cross product today. Sure.
okay.
Yeah, you
I'll
can
just
share
share
it.
my screen.
Yes.
Number 18, sir.
Okay, yeah. Can you please read the question?
Yes, sir. Two tugs are towing a ship. The smaller tug is 15 degrees off the port bow, and the larger tug is 20 degrees off the starboard bow. The larger tug pulls twice as hard as the smaller tug. In what direction will the ship move?
Correct. So here, why students find it difficult is because of the two terms used. So let's try to understand what are these two terms. So
Yeah,
port bow and the starboard bow, right? So these are the two technical terms which are being used, right?
right.
So, so two tugs are towing a ship. So let us say that this is our ship. Let me just draw a ship, something like this, right?
Yeah,
So where the the 2 points which they're kind of hooks here. Do you understand?
yeah,
So that if the ship is being tugged, then you can clamp on this, right? And then tug it. Do you see that pull it? Do you understand?
yes, sir.
So this particular point on the left side is the port bow. And the other
Okay.
side is the star bow. They just name it. So it's very easy. Like you go to go and clamp it to the star bow, right?
Yeah,
So the all the people working on the ship, they know what
yeah.
exactly is to be done. Right? So it makes things very easy for them to communicate. Now let's look into the question. It says the smaller tug is 15 degrees off the port bow. It really means, so in navigation, we normally use directions from north.
Yeah.
So 15 degrees is this degree which they are talking about. You get the idea?
Yes, sir.
And from the other, it is 20 degrees. So from the north, this angle is 20 degrees.
Yeah.
Then they have also said that the larger tug pulls twice as hard as the smaller. So let us say if this force is F, then the other force is 2F.
12.
You get the idea?
Yes, sir.
Now, in what direction will the ship move? That means we have to find the resultant, correct?
Correct.
So let me just share with you a whiteboard and then we can continue there. Make a bigger
Yeah.
diagram. And then it'll be easy for us to
Yeah.
solve the question, right? So basically, what we have done here is look at the ship as such. Okay, it's not that symmetrical. Okay, so now where we are saying that these are the 2 points of interest where this is being pulled at an angle. I'm making it purposely wider so that it
Yeah.
helps to understand the situation better, right? So, and this force, if it is F, then this force is 2F.
Yeah.
Correct. So we have to find the resultant force. Best way, what do you suggest? How do we find the resultant force in this case?
Sir, I'd say we can form a triangle, right?
But better will be resolve these forces into their x and y
Okay.
components,
Components. Yeah.
right? So for 2F, the x component will be what? This is 20, right? So if you see the x component is sine theta, right?
Right.
Or you could write this as 80 degrees and then you can also split. So,
Yeah.
so F of the second force, let me write 2x component will be, in terms of 20, let's write down, will be 2f sine 20 degrees, correct?
And so
And
if
the
we were
y
using if we were using cosine, it would be 70 degrees, right?
88 or 70 or 70, 90 or 70. So
Yeah,
2y component will be 2f cos of 20 degrees, correct?
20 degrees. Yeah,
In this case, it will be f1x component is f of sine 15 degrees, because that is this component, right? Do you understand?
right.
Opposite to 15, therefore sine.
Yeah,
And y component will be f cos of 15 degrees. Is it okay?
yeah,
So now, what is the resultant? Let's say resultant x component will be add these x components. They are in the
yeah,
opposite direction, right? So we're keeping
right.
right going where our nomenclature is this is positive and this is negative. Is it okay?
Negative. Yeah,
Up is positive, and therefore we'll write this as positive. So we'll write 2f sine of 20 degrees minus f
sine
sine
50.
of 15 degrees, right? You can
Right.
plug in and calculate the value.
Yeah,
Similarly, the y component will be 2f cos of 20 degrees plus, because both are pointing up, right?
up, right.
F of cos of 20 degrees, correct?
Correct.
Now, can you find what is 2 sine 20 plus sine 15?
Yes, sir. I'll just do that.
Minus sine 15. And what
2
is
sine.
2 cos 20 plus cos 20?
So for the resultant x, the force inside the bracket would be 0.425. Yeah,
And this will be how much?
and that will be 2.819.
Correct?
Yeah,
So therefore, now you get the resultant force. You are mainly interested in the angle, right?
right.
So as you can see, the resultant which you got here is the y component, which is Ry, which is given to you as 2.819, right? F.
Right.
And the x component is going in this direction, right? You
Right.
can see this. And so that is your angle, correct?
Yeah. So now you use tan theta, right?
Yes. So you say tan theta is equal, which is from the horizontal. Do you see? This is the
Horizontal.
yeah.
Yeah.
From the horizontal. Tan theta is 2.819f divided by 0.425f. F cancel, correct?
Correct.
So what is theta equals to?
Theta is equal to 81.43, sir. Rounded to the nearest hundred.
Okay. So 81.43 is your theta. And we want to give the angle from the north, right? So from
Right.
the north, it is 90 minus this. How much do you get?
So you get 8.57.
That is your answer. So from the north, it will be 8.57. Is it okay? So you will say,
okay.
so you will say from north, the answer will be from north 8.57 degrees east. Is it okay?
Yes, sir.
So that is how you're going to answer this question. Is it absolutely clear to you?
Yes, sir. It makes much more sense now.
Perfect. That is how you should give. All the angles in the navigation should be given from the north. Many
From the
times we use bearing angle, right? So
right.
if I have to write bearing angle, I will write bearing of, what is the bearing?
So it's measured from the north, right?
008.57 degrees. Three place values we have to give, not just 8.57. So it is going at a bearing of 008.57 degrees. You get the idea?
Yeah.
So measure from the north clockwise. So that is your solution for the given question. Perfect?
Yes, sir. Perfect.
Clear. Perfect. Now let's begin with cross product.
Yeah.
You remember when we talked about dot product, how did we begin? Vectors basically was introduced to explain or to model many physical things which we see.
Right.
Work done was an example of dot product. force times displacement. And that times is a special dot product in vectors, which is a scalar quantity, right? It does not
Right.
have a direction. Today, we are talking about cross product. So cross product example is that, let us say we have to screw, and then let's say this is the screw, right?
Yeah.
You have a wrench here, and you move the wrench clockwise. In that case, when you move the wrench clockwise, in that case, what happens to the screw?
So it'll start going down, right?
It goes down. So it has a
Yeah.
direction. What you notice here is that the force which is being applied and moving it clockwise pushes the screw downwards. So
Downwards.
that result has a direction.
Right.
So how do we explain this part? So depending on, let us say this is my force and this is the arm length, let's say R. So that is the force into R.
Right.
F cross R, which gives you the torque. We call this as the torque, P. And this torque has a direction as the resultant is going downwards, correct?
Downwards.
If I
Right.
reverse the direction, it will go upwards.
Upwards. Yeah.
So we need a very special product to represent this physical quantity. Perfect?
Yeah.
So which is called cross product. Now, one more thing which is very important here is we are always dealing with R3 in this case.
Oh, okay.
Because if I'm applying some force in one plane, then
Yeah.
the reaction takes place in another plane. Do you see that?
Yes, sir. Yeah, because the reaction's downward in this case, right?
Right. So do you see it just moves in a different direction? So therefore,
Right.
when you look into cross product, we are normally looking into three components, I, J, K, right? So we say along the
Right.
x-axis, we'll have I component, then J component, and K. These are the unit vectors along I, J, K. So we have to somehow understand how do we get the result by kind of a multiplication, which we'll call cross product, to get both magnitude and direction. You get the idea?
Yeah.
That is the whole thing. Perfect. So I will also introduce you to some more terms, which is introducing you to matrix
Yeah.
and determinants. Many times when we talk about vectors, before that, it is a prerequisite to understand what are determinants and what is matrix. However, for your particular curriculum, matrix and determinants is not yet taught to you, right? It is not a part of your curriculum. And therefore, I'll just tell you what it is and how do we use it to find the cross product. Is that clear to you?
Yes, sir.
Okay. So you've understood the concept that geometrically, we are looking for force being applied at a particular point, which is definitely at some distance, right? As shown here. But the resultant has a direction.
Yeah.
And therefore, the cross product will be a vector quantity, correct? So we
Yes,
get
sir.
a vector quantity, not a scalar quantity as we got in dot product. So
Dot
that is
product.
a major difference, okay?
Yes, sir. Sir, so for the cross product, right, is the only application force related?
Many. Well, there could be many, right? When you pedal your cycle, then things may happen, the gears may move.
Oh,
So
okay.
of course, force is a driving force. When we look into dynamics, so force becomes kind of a dynamic force. You apply force somewhere, right, and something else happened the other side. You get
Yeah.
that?
Yeah.
So all those things are happening. So force normally is a major driving thing, right?
Yeah.
Okay. Now, let me recall that when we say A dot B in the dot product, you found this using it is magnitude of A times magnitude of
B times cos theta.
Cos theta. In case of a cross product, when I do the cross product between the two vectors A and B, in that case, it is magnitude of A times magnitude of B times sine theta. So this is very important equation which you should keep in mind while working on the cross product. Okay.
Yeah.
Uh, so this is one thing. Second, let's keep in our mind the corner of the room. So when you look at the corner of the room, you have your
Yeah.
Cartesian 3D, right? You say,
Right.
well, this is my x, that is my y and z. And whenever I'm talking about vectors, I'm looking at the unit vectors ijk.
IJK.
Now, if I do, let us say vector, let's talk about I and j, because if there is another vector a here, it is a scalar multiple of I, right?
Right.
So if
Right.
I could teach you what is the cross product between I and j, you can understand what is the cross product between 2I and 3j. You get the idea?
3J. Yeah.
Because 2 times 3 will be 6, and then I and j are the vectors, correct?
Right. Yeah.
So it boils down to looking at cross product of I and j specifically. Is that clear to you?
Yes,
Others
sir.
are scalar multiples, right? You could always multiply with these magnitudes, correct?
Yeah.
Perfect. So what is I cross j? This is what we need to figure out. Now, the angle between I and j is what?
90 degrees, sir.
90 degrees. So this is a magnitude of I times magnitude of j times sine of 90 degrees, correct?
Which is 1.
Which is 1. So this is definitely equal to magnitude of I times magnitude of
Magnitude
j,
of J.
which is also 1, right? 1, 1.
Right.
So the magnitude part we have got. What is the direction? Now the direction of ijk is when I cross product of I and j, it moves up, right? Which is the direction of k. So
Right.
it is in the direction of k. Do you see that? So
Oh,
the
okay.
cross product of ij is k.
So, sir, to find the direction, right? Do we always do it the counterclockwise way?
Yeah, so you use the right hand rule. So
Oh,
if I move from I to j, you get the idea. Then the thumb
yeah.
gives me the direction. So whenever you're looking at any vector a and b, you see how a and b are positioned, and then the thumb will give you the direction.
Okay, so in this case, the thumb points upwards, right?
The thumb points upwards. If you
Okay.
curl your fingers going from I to j, right? Not from
Yeah.
j to I. You get the point.
Yes, sir.
Right? It goes up. Otherwise,
Right.
easy way is, as I've just shown you, I, j, and goes to k, right? So
Right.
what we do normally do is kind of make our, this is my cross product, right? So if I
Yeah.
move in this particular direction, I, j, k, I get the next thing. Do you see that? I, j, k. If I do k times I, means cross product, I get j.
Yeah.
So I times j is k, k
Is
times I
K.
is j, j times k is I. You get the idea. So you could
Yes,
move this
sir.
circle and get what the resultant is. Is that clear?
Yes, sir. Clear.
As far as the magnitude is concerned, you can multiply the numbers and you know the magnitude. Major part was the direction.
Right.
Now
Correct.
remember, if I do I times I, let us say if I do I times I, what do I get? I get magnitude of I times magnitude of I times sine of 0, right?
0. So
Sine 0
0.
is 0. So this is 0.
Yeah.
So the cross product happens only when you multiply two vectors which do not have the same direction. If they have
Yeah.
the same direction, result is 0. Yes, the result is 0, right?
Right. So, sir, it has to be two non-collinear vectors, right?
Yes, yes, yes. If they are
Right.
collinear, the result is 0, the cross product
Is
is
0.
0, right? As you can see. So now, does this formula make sense? A cross B is magnitude of A times magnitude of B times sine
Or
theta.
sine theta.
Get
Yes,
the
sir.
idea?
Makes sense.
And so with that, we kind of get a concept that
Yeah.
when we have the I part multiplied with the J part, the resultant is going to be the K part. Got it?
Right. Yes,
Yeah.
sir.
Yeah. Now, I will take up a vector multiplication now. Let's say vector A. Let me write down. So let us try to understand multiplication now.
Yeah.
So let us do A cross B, and I'm writing A as a vector. Let's say 2I plus 3j minus k, and vector b as, let's say, 3I minus 2j plus 2k, let us say.
Yeah.
Okay. Now we'll do the cross multiplication between these two. Before that, let me also teach you a part of determinant, which we are going to use soon. So if I have, let's say, P, Q, R, S, a determinant, then the value of this can be calculated by multiplying P with S and R with Q. So this is equal to PS minus R.
RQ.
Correct? So that is the value of a determinant, which we are going to use in the multiplication of these vectors. Is it okay?
Yes, sir. Got it.
Now, when you multiply this vector, I will write this in the form of a matrix with ijk as the unit vectors in the first row, then the coefficients of A and B in the second and third row. The coefficients are 2, 3, and minus 1. And here the coefficients are 3, minus 2, and 2.
And 2.
Correct?
Yes, sir.
Now, when you multiply cross product, then for I, we get this determinant. Let me just make a determinant for I. This is, I is being multiplied with this determinant. So we'll do 3 times 6 minus that. Do you see that, this part?
Yes, sir.
We can write this as I times 3 times 2, 6, minus 2 times, this is 2, minus 2. Is it okay?
Okay.
And for J, and we also alternate the sign, plus, minus, plus. With J, we have minus J. And J times, now for J, the determinant will be 2, 3, minus 1.
Minus 1, 2.
So you do 2 times 2, which is 4.
Minus 3.
Minus 3, because it is negative, it becomes plus. Is it okay?
Plus. Yeah. So, sir, with the sign alternation, that's like general, right? We have to do that at all times. Yeah. Okay.
So now with K, so these are unit vectors. We also write unit vectors with a cap on top, right? Like vectors, normally we write a straight line or an arrow on the top.
Yeah.
With unit vectors, specifically, we write a cap while writing. So I've switched to cap. With K, the determinant will be this part. Do you see that?
Yeah.
So 2 times minus 2 is minus 4.
Minus 4.
And
minus
minus
9.
9. Do you see? So we get our answer. 6 minus 2 is 4. So we get 4i.
Yeah.
4 plus 3 is 7, minus 7j. And minus 4 minus is minus 13k.
Yeah.
So that is how we are going to calculate the cross product. You get the idea?
Yes, sir. Got it.
So have a good look at it to understand what a cross product is.
Yeah.
In general, you also understand that A cross B is magnitude of A times magnitude of B times sine
theta.
And we have also learned that as far as I, J, K is concerned, I, J, and K, cross product of I with J will result into K, right?
K, yeah.
So that is how we move. And we apply the right hand rule. Secondly, we apply the right hand rule to find the direction.
Yeah.
Is that all clear to you?
Yes, sir. Clear.
So this is the basic of a cross product.
Yeah.
Perfect. So sine theta. Now, if the cross product is 0, it means what?
It means that the two vectors are collinear, right, sir?
That, yeah. So basically, you are saying that magnitude of A times magnitude of B is that
sine 0.
Sine theta, right? But if it is 0, and we are talking about non-zero vectors, correct?
Okay. Yeah.
So the cross product could be 0 if one of the vectors is 0. But if they are non-zero vectors and we do have a cross product, which is a 0 vector, in that case, it can be 0 only if sine theta is 0, right?
Right. Right.
So that means theta equals to 0.
Yeah.
Or it could be 180 degrees, correct? So that means the vectors are collinear.
Yeah.
Is that clear to you?
Yes,
so,
sir. Yeah.
Like in dot product, we found that the dot product is 0 means they are perpendicular or orthogonal. Right? So when I
Right.
say
Yeah.
A dot B equals to 0, which is equal to magnitude of A times magnitude of B times cos theta, right?
Yeah.
This implies that theta equals to 90 degrees, right?
90
So
degrees.
that means they
Correct.
are perpendicular or orthogonal.
Okay. So those two mean the same thing, right, sir?
Yes.
Okay.
The word orthogonal is used many times, so therefore you should know it.
Yeah.
Is that clear? So you can now compare the two, dot product and the cross product.
Yes, sir.
So when you do the dot product, you're multiplying i's with i's, j's with j's, and k's with k's.
In case it
But when you
case.
do cross product, so I component, you get product of j and k, right?
J and K.
That
Yeah.
is kind of important. Okay. So let me now take some examples from my YouTube channel so that you
Yeah.
understand it. Is this all clear to you?
Yes, sir. It's all clear.
Fine. So I'll just go to the YouTube channel and search. So now let me share with you my playlist on dot product and cross product. So
Yeah.
when you search Anil Kumar cross product or dot product playlist, you'll get many of them. So here is
Right.
one, vectors dot and cross product applications. Let's get into the applications. Uh, so there you go. So here are, okay. So some videos are here. So when we talk about dot product, cross product in this playlist, we have many examples which include both dot product and cross product.
And
Okay.
cross-product. Yeah.
So very intricate examples are there, but we'll begin with simple ones.
Yeah.
So here is a very important question. Simple 4-minute video. Let's look into this question, right? Given
Yeah.
vector A as 1, 2, 3 and vector B as 2, minus 1, 1, find A cross B and verify that it is perpendicular to both A and B. Do you see what do you understand from the question? Can you please tell me?
Yes, sir. So we're initially given two vectors and we're asked to find the cross product. And then I think they're asking us to verify that its dot product is 0 because if it's perpendicular, it's 0.
Yeah. Dot product with A or with B is 0. You get the idea?
Yes, sir.
Because the cross product is going to be perpendicular to both of them. Ij, when you multiply, you get K. Now K
Yeah.
and I direction is perpendicular, K and J is also perpendicular. You get the idea?
Sir, I think the YouTube stopped sharing.
Okay, I see. Let me share it. Is it sharing now?
Yes, sir. It's back up.
Perfect. So let's try to understand the question. Now let us say that we have two vectors A and B. Let's say vector A is shown in this. It's not very prominent. Let's say vector A is this, okay?
Yeah.
And then we have a vector B in this direction, right?
Right.
Then what is the A cross B? A cross B will be vector pointing out of the page. Do you see that?
Yes, sir.
So that means this vector A cross B will actually be perpendicular to both. It will be perpendicular to B, correct?
Right,
And
because it's pointing out, right?
perpendicular to A. You get the idea. Do you see the
Yeah.
diagram now? Do you understand?
Yes, sir.
Now read the question. Find A cross B and verify that it is perpendicular to both A and B. Only then your answer is correct. You get the idea.
Right.
So very important question. Simple 4-minute video, but it gives you the whole concept of the chapter. Now, so you should try and get this question. I will just move forward and show you what we have done here. But you should do such these questions from the playlist on your own, right?
Yes, sir. So, sir, for this, we also form the matrix, right? Yeah.
I have used matrix in most of my videos, but I've used
Yeah.
the method which you use in school also, not a problem.
Yeah.
So do you see that? So vector A and B. So I made that matrix with IJK,
IJK.
1, 2, 3, 2, minus 1, 2, minus 1, 1, and 1, 2, 3, right? So,
Yeah.
and then I is 2 times 1 minus 1,
Minus.
right?
So 2 plus 3.
Right. And then you get the vector C, which is cross product of A and B, as
and B
5i, 5j, 5k minus. Is that clear?
minus 5. Yeah.
Now, to verify that it's perpendicular, you have to find the dot product of C with A, right?
Right.
And the dot product should be 0.
Right.
Correct? That means
Correct.
it's verified. So it's a very good example where we are using both cross product and dot product.
Yeah.
As you can see, the dot product of C, which is with A and B, is 0, as shown in the solution. Is that clear to you?
Right. So, sir, we have to prove that C is perpendicular to A and B, right?
Correct. So separately, I have found what is C dot A and what is C
Okay.
dot
Okay.
B. And both
Yeah.
of them are 0, as shown here. Correct?
Yes, sir.
So that is the beauty of the question. And so now, do you get how do you find or calculate cross product? How do you
Yes,
verify
sir. I get it.
dot product? Very
Yeah.
beautiful, simple example. Is that clear to you?
Yes, sir. Clear.
Okay. So we'll take more examples on this. So here is a test paper, which is about an hour long.
Yeah.
I'd like you to, after the class, go through this particular test paper and solve some questions. I know it's too early. You have to do some more examples from the book before getting it. This is actual test paper I'm showing you. Can you just see the questions? The very first question, you remember we did
Yes,
that
sir.
early on, right?
Yeah.
Which of the following sets of forces acting on an object could not be in equilibrium? Very first question. We also did it in our very first class. You remember?
Yeah. Yes, sir.
What
We
is the
did.
concept? Tell me. How will you answer the first question?
Yes, sir. So I think we said that forces in equilibrium would sum to 0, right? So
Yeah.
forces not in equilibrium would be the opposite of that.
No. Equilibrium means they will form a triangle. And in a
Right.
triangle,
With
sum
equal.
of two
Yeah.
sides is always greater than the third side. You get the
Right.
idea? And
Yes, sir.
also see, the very student has got the very first question wrong. It is not an easy question to answer.
Yeah.
The student has got 38 out of 50, which is not a very good mark, you know that.
Yeah.
But still the teacher is saying good. You
Yeah.
understand the complexity of these vectors.
Yeah.
Still the teacher is saying pretty good. You get the idea.
Yeah.
So the vectors test could be very tricky, okay? And I
So,
picked,
sir,
yeah,
in this case, following the concept you said, right?
yeah,
The sum of two sides has to be greater than or equal to the third side.
yeah. So if the sum of two sides is not greater than the third side, then you cannot form a triangle. And then it is not
Okay.
going to work. Which of the following sets of forces acting on an object could not be in equilibrium?
So, sir, out of the three, if we sum two, it has to be greater than the third, right?
Yeah. In this case, all are greater than the third, right? Except for
Yeah, that's yeah.
fourth, but that is also in equilibrium.
Because if we add 10 and 5, we get 15, which is still equal, right? So it does form a triangle.
Does form a triangle, and this will be which of the following sets of forces acting on an object could not be in equilibrium?
Could not be in equilibrium.
Could not be. So the word is could not be. So that 5, 10, and 15 will be in equilibrium only if they are in the same direction.
Right.
Because 5 and 10, let us say east, and 15 is going west. You get the idea.
Yeah.
But if there is an angle between them, then B will not form an equilibrium.
Okay.
So could not be is very kind of critical. So B is the one which could not be. The others will form a equilibrium,
Yeah.
right? So this is kind of a tricky question, but whatever. And the questions before you, right?
Yeah.
Right. In my example, the third side was, I mean, it
Right.
was
Yeah.
very
Yeah.
clear-cut, right? Anyway,
So, sir, in a question like this, right? How do I know that we're only
yeah,
dealing
because
with
the
the
word is could not be, right? So that means the best possible answer you have to provide.
Oh, okay. Okay. Yeah.
So here is a constraint that this could be in equilibrium only if they are all collinear vectors.
Yeah. Okay.
There's a big constraint here. So the best possible from the given situation will be that. And
Yeah.
so you can go through this video about an hour long, which will give you right questions for your unit one. So unit one test. Is that clear to you?
Yes, sir.
And then you can actually watch some more videos and understand dot and cross product. Let's say
Yeah.
go to the end of this video. Okay. Now, here is another very interesting question. It is relating to dot product. The vectors a and b have lengths 2 and 1 respectively. The vector a plus 5b and 2a minus 3b are perpendicular. Determine the angle between a and b. You see now. The question
Yeah.
is very tricky. We are given that the vector a plus 5b and 2a minus 3b are perpendicular.
Right. So that means the angle between them is 90 degrees.
Angle between a plus 5b and 2a minus
2a
3b
minus 3b
is 90
is
degrees.
90 degrees.
But you have to find the angle between a and b.
And b.
You see the
Okay.
how will
Yeah.
it? You get the idea, right? So basically,
Yeah.
you have to find what is a dot b, because a dot b is magnitude of a times magnitude b times
8.
cos.
Yeah.
So when you do the dot product of this expression, right? So, and since you know that 5a plus, a plus 5b is dot product is 0, then you get an equation and you're given the magnitudes of a and b. So you can actually, from this equation, isolate a dot b and get the answer.
Oh, okay.
So very interesting question from
Yeah.
test point of view. So that is how you're going to do it. Now here, so here we have a dot product application which is on work done, correct?
Yeah.
So practical application, just as you do physics questions. Can you please read the question?
Yes, sir. A block slides 42 meters down a ramp that makes an angle of 60 degrees with the ground. Determine the mass of the block if 10,400 joules of work was done.
Work done is given to you, and then
Yeah.
you find the mass of the block, correct?
Correct.
You use dot product and then figure it out. So anyway,
Yeah.
that is how you could actually watch some of my videos and understand these concepts. Let's look
Yes,
into
sir.
another playlist where we are focused more on the cross product. Okay.
Okay.
So how do we calculate cross product? The way it has been taught in your school will be shown in this particular video.
Yes, sir.
It's important to know that also. So we have now two vectors A and B. So in general, A cross B is this particular form, which is given in many books.
Right.
It's difficult to remember the formula, right?
Yeah.
So that is why making the matrix is much easier, right?
Yeah, sir. The matrix looks much more
Easier.
simple.
And there is a simpler way of not remembering the formula but doing it. And this is what I'm trying to do. So in
Yeah.
that way, what happens is the vector A, which is A1, A2, we start writing with A2. Do you see that?
Oh, okay.
A2, A3, A1, A2, end at A2. So we start from the middle, A2, A3, A1, A2, and similarly we write B2, B3, B1, B2. You see that? So you
Yeah.
write these numbers in this particular fashion. And as I was saying in determinant, that when you multiply A2, B3, it will be plus in sign, but when you do
Yeah.
B2, A3, it will be minus in your
Minus.
sign. And the first is a determinant basically, which is I component.
Yeah.
You get the idea? It is
Yes,
the
sir.
I component. You get the idea? So
Yes, sir.
A2 B3 minus B2 A3 is the determinant, which is A2 B3. You get the idea, right? Same determinant.
Yeah.
So when you
So
multiply,
this method seems to be a little more confusing than the matrices one, right?
yes.
Yeah.
So here is what anyway. You could see this because your teacher probably will be teaching you this way of doing it or directly the formula. Very difficult to remember the formula. Therefore, matrix is very simple because we are going to
Yeah.
use matrix so many times later. Is it okay?
Yes, sir.
But anyway, you get your result by writing A2, A3, A1, A2, and then multiplying as shown here and getting the
Yeah.
components of I, J, K. So straight away I've written minus 1 times 3 minus 2 times 2. This is the I component, minus 3 minus 4. Right?
Yeah. Okay. Minus 7.
The J component, 2 times 1 times 3 minus 1, 2 minus 3, right? So you don't
Yeah.
alter, but because you have already switched the position, you get this cross product and you can write down the answer straight away. Is that clear to you?
So, sir, if we're doing the matrices way, then we have to alternate sign for sure, right?
Yes.
Okay.
That
Yeah.
is a standard international way of doing things. Okay.
Yeah.
But that is also another way of finding the cross. Some students find this convenient because it all
Yeah.
depends on you learn it, right?
Right.
So likewise, there are many examples in this playlist. 16 are there. And for example, can you read this question, please? Area of triangle. Yes.
Yes, sir. The points A 1 negative 20, B 314, and C minus 103 are given. Determine AB, BC, and CA, and show that AB plus BC plus CA is equal to 0. Determine the cross product AB times BC, BC times CA, CA times AB, and explain why the cross products above are all equal.
Yes. So very interesting question, which you may like to go through from this particular video. So this playlist has many interesting questions. I'd like you to explore and learn.
Yeah.
Once you've done few videos, then you should go to your book and attempt most of the questions. In case you have any difficulty, you can always share it with me. I can help you understand and solve those questions. Is that clear to you?
Yes, sir. Yeah.
Okay. So we can end the class now, but I'd like you to summarize what have you learned today?
Yes, sir. So today we went over the cross product, and before when we were discussing dot product, I actually expected cross product to be more complicated, right? But as it turns out, I like the way we approach with the matrices. It's very clear. So the way we set it up with I, J, K, and also the alternative method is nice too. But I think I'll probably use the matrices one as it's very like well defined.
Good. So keep up with it. Do as many questions as possible and share whatever difficulties you come. Okay.
Yes, sir, for sure.
All the best.
Thank you, sir. Have a great day.
You too. Bye.